So you have a fast response system, which is respiratory, and you have a slow response system, which is
renal,
metabolic, or the kidneys. Okay? So it wouldn't be unusual to see that the bicarbonate level is trying to rise a little bit too. Because remember, if bicarbonate rises, then is that doing what? It's making it more basic, right? And if you've got an acidic condition and you make it a little bit more basic, it does what? It compensates and tries to pull the 7.34 back into normal range. So we could have like a 29 bicarb, all right, and you would call this a respiratory acidosis with metabolic compensation, okay? All right? Because the body is trying to compensate to pull the pH back to normal. All right? Yes, ma'am?
So, however long, whatever period of time you would wait and test that again, and it was within the normal pH, would you expect the bicarb and the PCO2 to drop back to normal?
Well, once I got my pH into normal range, then I would start to see one of these start to renormalize, okay, or not continue to rise. In that particular circumstance, it just depends on how well the kidneys are functioning and how well the lungs are functioning as to which one is actually going to pull it into normal range, okay? Because as long as PCO2 is going up, if it's high, then the body is still acidotic from the respiratory side, right? Okay, so how will we get the pH to go to normal if the PCO2 is acidotic? What would you have to do? Anybody got a clue? All right, if pH is 7.34, it's acidotic. As it keeps rising, or I'm sorry, going slower, and more acidic, the lungs are trying to compensate and they make the body retain carbon dioxide, okay? So how will we get rid of the acid in this situation to try and shift things back to normal? What would the body need to do? It's trying to, yes. But again, which works faster, the lungs or the kidneys? The lungs. So
faster.
you would raise your heart rate, you would raise your respiratory rate to blow off more carbon dioxide. What?
Hyperventilate.
Exactly. Thank you.
Great job.
All right, that's it in a nutshell. So what the body's trying to do is it's going to start breathing faster, to blow off more carbon dioxide to try and bring the pH back down to normal, bring it up to normal, okay? I make the same mistake y'all do, because you think it's one thing and it's the other. But does that make sense to y'all? Okay, so sometimes you have to look at it a little bit deeper and say, what's the basic problem and then what's trying to compensate for the whole issue. In this case, it's all respiratory. Now, does that make sense to you guys? If you turned around and 24 hours later with that same initial problem of 734, what did I say, 49 and 29? If you came back 24 hours later and it was 7.35, 47, and 28, then what would you say? Okay, well, is the pH normal?
Yes.
Okay, yeah, but what way is it sitting? Is it more to the acid or more to the base? More toward the acid. So if it's more towards the acid, then the body's trying to compensate for it. And in this case, it actually did because pH returned to normal. So just by dropping the PCO2 just a couple of points, it pulled the pH up where it needs to be. And then what did the kidneys do in response? They renormalized their bicarb level. Okay? Make any sense? Yeah. All right, good. Excuse me. I'll tell you what. How you guys stay in heat in here? I'll never know. Y'all know me. I'm a hot-natured sucker, you know? I know. All right, so did that fully make sense? All right, so you can have a derangement in acid-base, and then the pH may be abnormal. If the body's trying to compensate, like we showed you in that first example, the bicarbonate's rising to try and make the body more alkalotic again, then you've got compensation starting to take place. It can be partial compensation, meaning that the pH is not back to normal, or it could be fully compensatory, and that the pH is now back into normal range like we got the very next 24 hours, okay? All right? So those are the different ways you can do it. All right, so how is that for the shortest presentation John Mills has ever given? All right, let's see. I need to. All right, let's see. Do. Okay, now pull out your handouts. All right, and I'm going to be sitting pretty much the rest of the time. So the way these are set up, there's a blue line here. The number 1 is on top, number 2 is on the bottom, 3, 4, 5, 6, 7, 8, okay? And that's the way we're going to go across the page on all of these. So let's see, the first one, pH is 7.31. Make sure I'm looking at the right one so I don't goof myself up here. Oh, very good. I almost had it right. Okay. So, on the first one we have a pH of 7.31. Is that acidic or basic? Acidic. All right. So, first thing you write next to it is acid. All right. Now, is the PCO2 normal? High. It's high. All right. So what's happening to pH? It's down. Remember, use the arrows, okay? It helps you remember. The pH is 7.35 or 31. It's down, right? PCO2 is high. Are they going in the same direction or opposite? Opposite. So what kind of disorder is this? It's respiratory, and that's exactly right, okay? And the bicarbonate level, what is it? For our purposes, it's normal, all right? So is this compensated or uncompensated? Uncompensated, because the pH is absolutely nowhere near normal. So what are we dealing with here, folks? Respiratory acidosis. Let's see, Susan. Torchia. Well, give me a break. All right. Tucson torchia. Look at number 2. pH is 7.31, PCO2 is 55, and bicarb is 35. So what do you think we're dealing with?
We're dealing with a compensated respiratory acidosis.
Okay, what tells you it's compensated?
The bicarb.
Okay, is the pH normal?
Oh, that's right.
All right, it can't be compensated if the pH is abnormal. Okay? So we got a pH of 7.31, and that is what? It's an acidosis. And then what's the biggest arrangement you've got? pH is going down. What's bicarb doing? I'm sorry, what's CO2 doing? It's opposite. It's going up. So the initial problem is, Susan? Respiratory acidosis. And what's bicarb trying to do? It's trying to correct it. That's exactly right. Okay? So the kidneys are kicking in. That's why you've got that high bicarbonate. This is what you call a mixed acid-base problem. Okay? And you're going to see these a lot, especially in patients with kidney disorders and stuff like that. Okay? You also see these kind of problems in patients with chronic obstructive pulmonary disease and bronchitis. You got that? Y'all got bronchitis? That's a problem of Walter Cronkite, right? Cronkite? Right. Okay, chronic bronchitis. So people with primary lung disease are going to have blood gases that are going to often look like this. And they're never actually going to get their pH back to normal range because they retain CO2 on a regular basis. The kidneys have long since tried to compensate and kick the acid-base balance up to normal, but they just can't keep up because the person keeps retaining carbon dioxide. Okay? Does that make sense to y'all?
So what is that one called?
It's an uncompensated respiratory acidosis.